All right, let's talk about one of the biggest oops moments in the history of science. This is the story of how we figured out we weren't just wrong about our place in the universe, we had it completely backward.
So think about this for a second. What if something you believe to be a basic fundamental fact, something everyone has known for centuries, was just wrong? A massive, collective mistake. Well, that's exactly the story we're diving into today.
You know, for most of human history, we all thought we lived in an Earth-centered universe, a geocentric universe. And here's the thing, it made total sense at the time. This wasn't some silly guess, it was a really logical conclusion based on what you could see every single day.
I mean, just think about it from their perspective. Every day, you watch the sun rise in the east and set in the west. It looks like it's going around us. Every night, the moon and stars do the same thing. And maybe most importantly, you don't feel like you're hurtling through space, right? The ground feels perfectly still. The obvious answer, we're the stationary center, and everything else is revolving around us.
So this whole story really boils down to two competing models. You've got the geocentric model, where Earth is the star of the show, sitting right in the middle of everything. And then you have the heliocentric model, which kicks Earth off the throne and puts the sun at the center. This is the big cosmic showdown.
And don't get me wrong, the Earth-centered model wasn't just some old folktale. It was serious science for its time. Brilliant minds like Aristotle and the astronomer Ptolemy built this incredibly detailed system. And for nearly 1,400 years, this was it. This was the accepted truth.
But there was a problem. A little nagging detail up in the night sky that just didn't quite fit. A puzzle that, no matter how hard they tried, just wouldn't go away.
And that puzzle was called retrograde motion. See, ancient skywatchers noticed that some planets, like Mars, would do this weird little dance. They'd be moving across the sky, then they'd slow down, stop, move backward for a few weeks, and then continue on their way. Now, how on Earth could that happen if everything was moving in perfect circles around us?
Well, the fix was clever, but man, was it complicated. Around 150 CE, Ptolemy came up with this idea of epicycles. Basically, he said that planets weren't just moving in one big circle around Earth. No, they were also moving in their own little mini-circles as they moved along the bigger circle. It kind of worked to predict where planets would be, but it made the solar system seem like a ridiculously complex machine. So after centuries of just adding more and more complex patches to this old theory, the stage was set for a revolution. And that's when a Polish astronomer named Nicholas Copernicus came along with an idea that was just so simple and so radical. The year was 1543, and Copernicus basically said, hey guys, what if we're not the center? What if the sun is? This one simple idea was about to turn more than 1,000 years of science and philosophy completely on its head. And what was so beautiful about Copernicus's idea was how elegantly it solved all the old problems. Day and night? Oh, that's just the Earth spinning around once a day. The sun moving through the sky over a year? Nope, that's just us orbiting the sun. And that weird retrograde motion? It's just an illusion. It's like when you're in a car passing a slower car. For a moment, the other car looks like it's moving backward. It's all about our point of view as we lap the other planets in our orbit. Now, you'd think everyone would say, wow, that's so much simpler, let's go with that. But no, not at all. This idea was a huge deal. It challenged centuries of tradition, philosophy, and religious belief about humanity's special central place in the cosmos. A simple, elegant idea wasn't enough. People needed proof. And this is where the story gets really good. Because what the world needed was cold, hard evidence, a smoking gun. And a guy named Galileo Galilei, with his brand new invention, was about to provide it. So in the early 1600s, Galileo points his new telescope up at Jupiter, and he sees these 4 tiny little stars dancing around the planet. They were moons. This was a bombshell. For the first time, humanity had proof that not everything in the universe revolved around the Earth. There was another center of motion out there. But if that wasn't enough, this next discovery was the absolute final nail in the coffin for the old model. Galileo pointed his telescope at Venus and saw that it went through a full set of phases, just like our moon does, from a tiny crescent to a full disk. Now that's only possible if Venus orbits the sun, allowing us on Earth to see different amounts of its sunlit side. In the old Earth-centered model, this was physically impossible. Game over. So, the model was almost perfect now. There was just one last little tweak needed. And that's where Johannes Kepler comes in. He figured out that the planets don't orbit in perfect circles like everyone had assumed for centuries. They actually move in slightly squashed circles, or ellipses. And with that discovery, the new sun-centered model became incredibly accurate.
When you look at the timeline laid out like this, it's pretty staggering, isn't it? You have this enormous gap, almost 1,400 years, where one idea just completely dominated. And then, bam, in less than a century, a rapid-fire series of discoveries from Copernicus, Galileo, and Kepler completely rewrites our map of the cosmos.
So who cares, right? Why does this big game of cosmic musical chairs actually matter? Well, it was a huge deal. The impact of this shift went way, way beyond just astronomy. It changed how we think about, well, everything.
This was really the dawn of a new era. For the first time, it established that what you can see and prove with evidence matters more than what ancient authorities wrote in a book. It taught us that science moves forward by questioning everything, even our most deeply held beliefs. It gave us a new, more humble place in the universe. And honestly, this whole episode lit the fuse that launched the scientific revolution and created the modern world.
And that leaves us with one last big question. This whole story is a powerful reminder that what seems completely obvious to us today could be seen as a huge mistake by people in the future. So it really makes you wonder, doesn't it? What obvious truths are we all believing right now that are actually just waiting to be overturned?